Hello again, Year 9s. Welcome back to mathematics. Now, in yesterday's lesson, we went through what Pythagoras' theorem told us. So we went through Pythagoras' theorem, which is on the screen here. A squared plus b squared is equal to c squared. And we saw how it related the lengths of the three sides of my right angle triangle. I'm just going to quickly go through that again. So if you remember, for any right angle triangle, so right angle there, we've got three sides, and the first side that we always identified was the hypotenuse. So hypotenuse, the longer side, which is opposite the right angle. So if you have a look right across the right angle, I have this side over here. That's my hypotenuse. It's the longest side of my right angle. Okay, cool. And I'm going to label that C. And then I've got my two other sides, and I'm going to call them A and B. So the relationship that Pythagoras' theorem told us was that if I square the lengths of the shorter sides, so A and B, if I square A, so A squared, and I square B, B squared, and add them together, I get C squared, the length of the hypotenuse squared. And that's what I have on the right-hand side here with Pythagoras' theorem. What we're going to do in today's lesson is we're going to be applying Pythagoras' theorem to help us actually find the lengths of missing sides in triangles if we're only given two sides. So imagine you've got a right angle triangle and you've only given two lengths. So for example, in this particular case, we're going to be looking at the case where the length of the hypotenuse is missing. So we don't know what the hypotenuse is, but we happen to know what our two lengths here, C and A and B, are equal to. If we know the side lengths of at least two sides of my right angle triangle, I can use that to help find the third side. And this is how we do it. So what I've got here is a list of steps that we use to find missing lengths using Pythagoras' theorem. Now, if you're writing this in your books, please write this down for me. It's really important. So if you need to pause this after I finish going through it, feel free to, but I need you to copy this down in your book so that you have a record of it somewhere and you can follow along. Okay. Now, when we're trying to find the length of missing sides using Pythagoras' theorem, I'm just going to zoom in here. The first step is we write out Pythagoras' theorem. So we write Pythagoras' theorem. Now, earlier I think I've said when you're using a formula, always write out the formula. That's something I've always said about using formulas. So here, Pythagoras' theorem is just another example of a formula that we're going to use. So if you're using Pythagoras' theorem, it's really important that you write out Pythagoras' theorem as your first step. So all you need to do is just write in your workbook, C squared is equal to A squared plus B squared, for example. Okay. So it just reminds you what you're actually using to solve this question. Okay, so that's the first step for Pythagoras' theorem. We're using Pythagoras' theorem to find the missing length of a hypotenuse. The second step is to substitute the lengths of the shorter sides. So i.e. the values of A and B. So when you're using Pythagoras' theorem, what you do is you substitute the values of A and B. So in your right angle triangle, you'll be given the two lengths of the shorter sides, A and B. You substitute those values into your Pythagoras' theorem. So instead of writing A squared plus B squared, you would write the value for A squared plus the value of B squared. Okay, so that's the second step. First step, write out Pythagoras' theorem. Second step, substitute the values of A and B, so the shorter sides in. The third step is you square them and then you add them. So you just square A and square B and you add the two together. Nothing else to add in that step, luckily. And the final step is you take the square root. Now, if you have a look at Pythagoras' theorem, which is what I wrote in the top, in the first line, I'm going to highlight over here, what you notice is that we don't actually have just C. If you notice on the left-hand side, we have C squared. That's not actually what we're looking for. We're not looking for the square of the length. We actually just want C. So if we want to get rid of that square sign, we need to take the square root. Taking a square root just undoes what the square is, what squaring does. So here we want to take the square root. So let me write that underneath. So here I'm just going to say i.e. c is equal to the square root of a squared plus b squared. We don't want just c, we don't want c squared. We want the actual value for c, so we take the square root. And there's a button on your calculator which helps you do this, to help for that. Okay, what I'm going to do is I'm going to go through a few examples to help show you how we do this. So let's have a look here. Find the length of the hypotenuse in this right-angled triangle. Okay. Also, just let me scroll back. Please write this in your books if you haven't already. So pause it if you need to at this point and just write these 4 steps in your book for me, please. Okay,